Welcome back for video number 4. So, in this video, obviously as you can see, we're picking up right where we left off in the third video, which was on collision control for our unified paths. But it's actually important that I mention collision control, linking, even tool axis control. These are kind of ubiquitous throughout the 5-axis path, or at least most of them, especially the module works paths. If you have an issue in SWARF or something like that, you can probably gain some understanding from this video as well. Without further ado, let's go ahead and go into we'll close our collision control, and we'll go into our linking. And I'll expand this. All right, so to start out, I'm going to skip entry, exit, default links, and we'll come back to those. What I want to start out with is our clearance area and how this is used. All right, so you can see here, it's set to 6 inches. It is set to a plane. It's set to the direction WCSZ axis. Essentially what that means is it's creating a plane, WCSZ axis at 0. It's saying go 6 inches above that. Okay, so first off, I'm going to change this to be 1.0, and I'm just going to hit check. So you can see automatically looks a lot more reasonable, right? So we fixed a lot of those retract problems where it's going way up without really too much trouble there. Okay. We have 3 options. Well, we have 4 options in here. We have automatic, we have plane, we have cylinder, and we have sphere. Which one you use depends entirely on what the shape of your part is and what you're doing to that part. So in this case, where I am machining essentially a flat surface that is aligned with a normal plane, for the most part, it's basically coplanar with the WCS plane. It makes sense for me to do plane here. It doesn't make sense for me to do anything else here. And that's what I'm doing. So this would be ideal for what I'm doing here. Now, the question is, when would you use automatic? When would you use cylinder? When would you use sphere? I very rarely use automatic. Sometimes maybe I'll just try it just to see what it gives me so I don't have to specify anything. But I actually really prefer to have that control. Automatic is just going to choose which one it thinks out of these 3 is the best. So it's not going to choose some special shape that doesn't exist. It's just going to choose one of these 3. Now, that being said, it can choose to create a custom plane where it's retracting to a custom plane. In fact, let's just give it a shot. It might even do that for us here. It definitely did not. It looks like in this case, it actually looks like it may have picked a cylinder or a sphere in this case. It's not easy to tell which one it picked. But it would appear, it actually appears that it picked a sphere in this case. Yeah, it did pick a sphere because of the angles of these. So it's actually coming out as a sphere. So that's probably not the most efficient for this. So automatic doesn't always give you the best result. So if we go back to plane, you can see there, that's probably a little bit more efficient for what we're doing here. Okay, the clearance area, so we can just pick essentially which plane it's going to use. So if we pick plane and we pick automatic, this may give us a custom plane. Oh, it doesn't like that. So it ain't going to work if you pick automatic all the time. So I'm going to go back and I'm just going to pick my WCSZ. Obviously, if you were doing something on a different plane, you may pick a separate plane, like a front plane or something like that. Tool orientation, I generally leave this to automatic. And user defined is usually what I leave for my height. That way I can put a custom height for my retract. Remember, this is just your clearance area. It's just defining where it's going to go to when it goes to its clearance area. Let's go ahead and take a look at cylinder. So when would I use cylinder? Well, a lot of times when I would use cylinder, I'm actually looking for something on my desk right now to kind of demonstrate. A lot of times what I would use cylinder for is if I had a part that I was doing a lot of machining around the outside of it, what I would do is I would actually create that cylinder. So it'd be a cylinder this way, and if I was machining around it, I would just want to retract out this way, have it rotate, machine it, have it pull out, rotate, machine it. So that's really when cylinder is used a lot. If you think about this base here that my cursor is over, of that being held in the vise, and then you're creating a clearance cylinder. So it's going to retract up out, rotate, come back down, machine, and continue, basically repeat that process. That's when I use cylinder. Let's take a look here. Let's say I'll make this 4 inches. So I'm basically defining the radius of my cylinder. Of course, you can define the direction and all that good stuff. So I'm going to go ahead and hit check. Okay. So now you'll notice that everything, if I go to right side plane, notice that all of my retracts are coming straight out, and they're coming out to essentially a 4-inch radius. So if you created a cylinder here, it would be an 8-inch diameter cylinder, and they're just coming out to that so that it can rotate and clear. Now again, that only makes sense if you're machining around the outside of something like this. For what we're doing, it doesn't really make sense for us to do that. We would use a plane in this case. The other option is our sphere. And this is what automatic actually gave us. We'll keep it on a 4-inch radius for the sphere. So it's just going to retract out. And now you can see it's just coming out to anywhere. If you imagine a sphere around here, it's just coming outside of that 4-inch radius or 8-inch diameter sphere to reposition to another point. When would I use this? Well, I would probably use this if I were machining something like a sphere. Would be a great time to use it. Obviously, you're machining a sphere. At any point, you could be at anywhere around that sphere. It would be more efficient to just come right off to a spherical clearance, and then when it moves to the next place, it's going to stay that distance away from that sphere. Things that would kind of lend themselves good to a spherical clearance maybe be like, if you're machining something that was fairly square in shape, fairly round in shape, it wouldn't be something that's elongated like a cylinder, or else you'd use cylinder. It would want to be something that would fit well within a sphere. And if you were machining all sides of it, so if not just machining around the outside, but also machining the top of it as well, you may want to pick sphere for that. Again, you can try these. Give them a shot, see what they look like. I could tell just by looking at that is not efficient for what I'm doing. So I'm going to go back to my plane. I'm going to select my plane. So I don't always know what the best one's going to be. Usually I could pretty much surmise just from experience. And the more you do this, the more you get that experience, the more what to probably pick. And then sometimes every once in a while you have to go back and you have to change it because it doesn't give you the result that you want. So let's go ahead and go back to plane. Essentially, that's how we create our clearance area. So that's how we specify where it's at. Let's see here. So I'm not going to go over this incremental clearance plane. We're not going to go over, we'll talk about these distances a little bit. So these distances are essentially that's just your rapid distance where it's rapiding out to, and then it's going to the clearance area. Your feed distance, that's where it goes to before it feeds in or feeds out. Exit feed distance, here's your feed out distance. And then air safety moves, it's just where it's going to move to be safe from hitting anything. And they'll coincide with these when we get into these here. So let's take a look at our default links. So let's go ahead and check here. I want to get this back to the way it was. Okay. So what I'd like you to notice here is we have, we have some examples here where it's kind of retracting. It's maybe coming over here, coming back down again. And maybe we don't want to retract. Maybe we just kind of want to feed over to that area. So we can do that with some of these options. We can get rid of some of these linking issues and some of these rapid, these clearance planes. So under default links here, we have small gaps and large gaps. So what it's telling you for the small gaps, it's saying use a blend spline. So it's going to blend it together with a feed move. In many cases, it's a fast feed move. That's what is illustrated here in purple. So it's just blending it together. Notice how it's kind of tangent. It's really smooth motion there. That's what it's doing. Now, you'll notice it's doing it here, but it's not doing it here. Well, how does it determine whether to do that or not? Well, we have small gaps and large gaps. Large gaps, they're retracting to the clearance area. These are considered large gaps. How is that decided? That's decided right here, small gap size. So if we're doing 100% of our tool diameter, obviously anything that is bigger than 0.375 is considered a large gap. So any distance bigger than that, it's going to retract the clearance plane. Any distance smaller than that, it's going to connect those with a blend spline. All right, so let's see what would happen if we change this. And I'm going to use a value here. I'm just going to say, let's make this 3 inches and hit check. And let's see if that changes anything. Okay, so that got rid of quite a few different retracts. So you can see right here, now we have this blend splines coming all the way over here. And that actually might be better for us. That might be what we want. Might be quicker than retracting, coming back in, feeding in, and then starting our toolpath again. So you can kind of play with that to get the best, most efficient toolpath possible. And it's just a matter of your small gap size. So you can also just change your large gaps to just do blend spline as well. Usually you don't want to do this. It's going to create some really wild stuff sometimes, so you got to be careful with it. But in this case, it actually seems to work out pretty reasonable, probably because we're just working with a 2D plane. So I generally just leave this on, where is it? Retract to clearance area. I usually leave this to retract to clearance area just to be safe, because if it's going a far distance, I probably want it to come up and get out of the way of anything so it doesn't hit anything. Some of the other options here, we have direct. So direct is just going to be a straight line between. It's not going to blend them together. So you notice right here, it just connects them with a straight line. Let's see here. So we have follow surfaces. So essentially, this is just going to follow the surfaces. In this case, not actually sure what it'll do with the 2D surfaces. It's not, so you can see it's not completely different from just direct. Follow surface is good if it's a curved surface. So what it's going to do is just going to follow that surface to get to its next point. In this case, it's just a 2D flat surface, so we're really not seeing anything different between that and direct. All right, retract to feed distance, that's just going to go to this distance here. Retract to rapid distance, that's going to go to this distance. You could probably figure this out. Then you could do retract to incremental clearance area, so you could set your incremental clearance area here. Just depends on what you're doing. And say you have the same options here as well. Now, if I am going and I'm using a blend spline, I'm probably not going to use my lead in and lead out. It just depends on what I'm doing. So if it's a 2D surface like this, I'm not going to use it, but I may use a lead in and lead out if I'm on a 3D surface and I need to lead into it. In other words, my blend spline's not blending in very well. Maybe I'm getting little gouges where it's leading in. Then I can add a lead in, lead out to help smoothen that transition. My first entry, I pretty much always want to lead in for this. So you can see here I don't have that. It's just coming down and it's just going to town there. So you can change your approach. I always approach from clearance area and I always retract to clearance area. Very rarely do I ever change this up. A couple of times retract clearance through tube center. I will use that if I'm doing some porting or something like that, but usually I'm just retracting the clearance area. In these, you can actually say lead in, use lead out. and now it'll lead in and lead out at the beginning and end of your toolpath. So it's going to use the default. So you have to go in and you have to select down here and set your default. And there are a lot of options in here. I am not going to go through all these options, but you can just try them. So like we could just do tangential arc for our lead in here. And let's see what that gives us. I don't think that's our initial lead in. Oh, there it is. I was in the wrong place. So right there, we have this tangential arc. So it's coming in at our tool angle, and basically it's using our tool tilt, and it's making it true or normal to our tool tilt angle, and it's just leading in to that. Other options here, do another one quick. We'll do a reverse tangent arc's kind of goofy. This is when you kind of need to get up against like a surface to lead in. If there was like a surface here, you need to lead in and then go back, you can use reverse tangent arc. Vertical tangent arc. Let's check that one out. So now you can see essentially it's using the direction of the tool. So it's kind of changed. It basically rotated my lead in 90 degrees. So it rotated it essentially from being like this. Now it's tilted like this, and it's leading in like that. So you really just have to see what works best for your situation. There's no right or wrong answer on these. I could use either of those two for this. It wouldn't make a difference to me. So I would probably have used the first one, but this one would probably work just as well anyway. So yeah, you could set those in here. You could change the size. Size is probably a little crazy on that right now. We could also make this like 45 degrees, and then we can copy it over. Make sure that we got the same thing on both, or you can keep them different. So see now, it's not 200 anymore. It actually has a very small lead in, so it's not this excessive ramp or excessive tangent lead in that you have there. So that's how you control your lead in, lead outs, at least for the beginning and ends. Now, if you want to create lead ins and lead outs, this I almost always have used lead in, lead out. And you can actually change your first entry lead and separate it. You can do gaps along cut. You can really specify your last lead in, links between passes. You can really fine tune this stuff. I'm not going to go through all of this. This video would be probably 50 minutes long if I did. But you can play with this stuff and you can really specify like, hey, I wanted to do this in this situation. I want to do this in this situation. This is how you do that. But I usually almost always use lead in, lead out for our retracted clearance area. And that's just because I'm coming back in. It's just like entering the first time. So now you would see here, you have a little bit of a lead in. It's hard to see it there. So right there, there's one. Now we're not getting one here because this isn't actually retracting to the clearance area. So we could go in here and try and play with this and see what we can do to get these to lead in and lead out. I suspect that the reason for this is because of our collision control is doing this. So this is where you can come into these and you can kind of play with gaps along cuts. And we're saying use default links. So these really should be using the defaults. And what we'd probably have to do here is, because these are considered small, so this is actually considered a small gap because you can see right here it's doing this blend spline between them. We would actually use lead in, lead out, and hit check. And now you can see it's doing a much smoother transition there. So now we've pretty much got lead in, lead outs everywhere, even over here. So that's going to create a nice smooth transition into the material. So it just depends on what you have. Obviously I didn't need to do that for these spots, although it did add them. The blend spline usually will do a nice transition in and out, But some spots over here being that example, we saw that it was just coming down and, basically plunging into it. Now, if this is an air region over here, then it doesn't really matter, right? We just plunge into that and then we're going to enter the cut. So you don't really need to lead in, lead out if it's an air region. And that is about all I have to go over here. That's essentially it. So hopefully this helps. Actually, I'll add one other thing. We do have some cool, I'm not going to go through it, but we do have some cool stuff here where you can actually control your feed rates. You can limit them in certain situations. So you can change your blend spline feed rate. See, like inside, outside feed rate. So you can really get it to change those feed rates and customize that. And we've used this in some situations before. And it's pretty awesome. Some of these are some more advanced settings, and probably not going to go into those today. So what I would do is I would say stay tuned, and what we'll do is come through with some more videos, some more advanced videos. We'll get into some more detailed stuff where we need some very specific geometry to demonstrate it. But yeah, if you have any questions, just post them in the comments, and give me a good idea of some of the stuff that maybe I need to create videos about in the future. All right, hopefully this was helpful, and enjoy the rest of the videos.